People, so we are doing a sample problem 6.2. I don't know what problem it is, um, but we'll figure that out later. Okay, we don't really need this, but I always like having a balanced chemical equation, so I just like keeping it. But let's read this problem. When 1 mole of methane is burned at constant pressure, so remember, delta H at constant pressure and only at constant pressure, delta H is equal to the heat flow at constant pressure. Okay. Did I forget a negative? I feel like I'm forgetting a negative. No. All right. So it tells us 890 kilojoules of energy. So 890 kilojoules of energy is released at heat when 1 mole is burned. So what we do is we call it 890 kJ for 1 mole, and it's a CH4. Okay, 1 mole of CH4 releases that much energy. That's what this value is telling us. And I kind of don't like this. It looks like when you write a project and your hand begins to drift. Feels like that. All right. Okay, hello. There we go. So we have this conversion factor. We know this stuff. But we also know that we don't have 1 mole of CH4. We have 5.8 grams of CH4. All right, and we don't like working with grams. I've already told you, whenever you got grams, turn that to moles, and with moles, you can figure your life out a lot better. All right, so 1 mole of CH4, well, what's its molar mass? Carbon is 12.01 grams, and 4 hydrogens, that's 4.00 grams. So this is going to be 16.01 grams of CH4. And let's do a little bit of math. Do we want moles? We don't want moles. We want to find the amount of energy that this amount released. So let's, in fact, multiply by this factor over here, this conversion factors. We know that 1 mole has that much energy, and we're at moles. So now look at our units. Like we got grams of CH4, grams of CH4. We have a mole of CH4, mole of CH4. The last thing we're going to get is kilojoules, and they want us to find our delta H. So let's do this math really quick. 5.8 grams divided by 16.01 times 890. And this right here is going to be 322.42 kilojoules. Now, is this the correct answer? Remember that heat has a direction. Heat has a direction, so it's up to you to really determine which direction that's going. It's not more or it's not less. Remember, if it releases heat, it's negative. If it absorbs heat, it's positive. So let's go back and read the problem and see which type it is. When 1 mole of methane is burned at constant pressure, 890 kilojoules of energy is released. So since it is released, it is negative. So that right there gives us the amount of heat or the amount of energy or the enthalpy of 5.8 grams of methane. All right, and units, oh Lord, negative 320 kilojoules. All right, we're not that accurate or precise, whatever. All right, that's it, people. Hopefully this helped with enthalpy. What we're going to talk about next is I'll give you an explanation for what calorimetry is and how it ties in with enthalpy. I'll see you guys then. If this helped, or if you need more examples of these types of problems, just ask and I can upload more. If you don't like a single problem, I can do 2, I can do 3, maybe 2.